All right, SLers, we're jumping into chapter 10, ABCD. We're looking at trig functions. So we're actually going to graph these and make equations out of them, thinking about the unit circle and the trig that we've done. So I want you to think about a unit circle, and then we're going to look at the sine of these functions as we change this arc length. So let's look at this. So we're talking about the sine when our angle is here at 0. So we're down here at 0. And so our sine, our distance up, should also be 0, right? So we can kind of fill that in. Once you get up here to pi halves, our sine is 1. We're up all the way up on the unit circle. That's 1. When we go back to pi over here, we're back to 0. And then when we get to 3 pi halves, we're down here at -1. Cool. And then once you get back to 2 pi, you're back to 0. Yeah? And then when you're looking at 5 pi halves, I mean, this was starting from 0. This is 1 pi halves, 2 pi halves, 3 pi halves, 4 pi halves, 2 pi, right? One more is 5 pi halves. 6 pi halves is 3 pi, etc., etc. So we're just going by pi each time. Pi halves, excuse me. This is just going to repeat, right? You're going to have the same thing oscillating over and over again. So when you're back here at 5 pi halves, you're up to 1, right? Here, 3 pi halves, you're back here at 0, back to -1, back to 0, etc., etc. It just repeats. Cool? So we like graphing sine and cosine because they model periodic behavior, and our whole world is periodic behavior. Climates are periodic, tides, phases of the moon, animal populations, even things like talking about light is an oscillating wave, and subatomic particles behave with this oscillating pattern as well, which is pretty sweet. And so as you get into particle physics, you're talking about oscillating behavior. So we like talking about periodic behavior. Cool. Periodic behavior is just sort of modeled by waves, and it's easiest thought of as waves. And waves have a couple of things that we're used to, one of which is they go from a maximum to a minimum, and they sort of have a halfway point. And one of the things that the IB calls this equilibrium point, this halfway point, this average, they call it the principal axis, right? And it's sort of like the level of the water in a pond when it's flat, right? So like this is the level of the water. And if you throw a big stone or a shoe in the water, then it's going to make ripples, right? So like you toss this thing in, and the water will ripple, and going down and up, and we call the amplitude, the size of the wave, we call that the distance from where the water usually is up to the maximum, which is the same as from the equilibrium, where the water usually is, down to the minimum, right? So if we know a couple of things, I mean, if we know the height of this is like, this location is at 10, the y is 10 here, and we know the y is 20 here. What's right in the middle? Well, 15. So this equilibrium point has to be 15 because it's halfway between here and here. And so therefore the amplitude is going to be 5, right? Even though it's 10 between the maximum and minimum, it's 5 between the maximum and equilibrium, or minimum and equilibrium. And that's all this says. Cool? Great. All right, so periodic behavior just means repeating behavior. So this is what we typically think of when we think of repeating behavior, just nice curving up and down. Bop, 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 bop. It's really easy to see the repeating pattern, so this works out. Ding, that's repeating behavior. This guy, it's sort of repeating. It's definitely symmetrical across this axis, but because this is changing and going down, I'm not really sure what's happening here, right? Here and here. This is not periodic, or at least we don't have enough information. Same thing here. This, from what we see, is not periodic just because it's changing a little bit, little by little, so not periodic. This, even though it has some of these little jaggedy points here and here and here, it's repeating. The pattern's repeating over and over and over again, so this guy's periodic. Cool? Great. All right, on to the good stuff. So here's section B. We're looking at the sine curve. So a unit circle is talking about one revolution. Its period, the time it takes, or the amount of rotation it takes to make one full revolution is 2 pi. So in a unit circle, the period is 2 pi. To go all the way around, it's 2 pi, right? Great. So if we were going to model the sine function, we're going to talk about, okay, hey, let's let my y's be the sine of theta, sine of our angle, and let's go with radian measure. Okay. Well, we know a couple of things. I know that here when our angle is 0, right? When we're here, our height is 0 as well. Yeah. And as we increase to here, pi halves, our height goes up to 1. So our height goes up to 1 here, right? Because this distance is a 1 unit, right? And then when we go back to pi, when we're over here, this height is back to 0. So we're back here. And then when we go to 3 pi halves down here, our height is -1 because this is a unit of 1 and we're going downhill, right? And then as you come back up to here, back to 2 pi, our height above the x goes back to 0, right? So you've got one oscillation right there. And you can just keep cruising around the unit circle, and this will keep creating wave and wave and wave, right? So a couple of things to notice is that the amplitude's 1. It's like this distance from equilibrium point up to the maximum, or equilibrium down to the minimum. And our equilibrium is here at 0, right? It's along this line. This is 0. It'll keep going forever. Its maximum and minimum are 1 and -1. Cool. And you can kind of, here's another way to look at it. You can kind of see it here when we, this is a great tool. You can check it out and mess with this yourself. It's just a nice little website. Looks like this. Here's our unit circle. Here's the sine wave, and this little green dot is this little green dot, right? So as we drag this up, oh, why are we back there? As we drag this up here, let's start at 0, right? Now let's go up. Oh. I don't know why it's just going along that line. Reset. There we go. Okay. All right, let's try that again. So this guy, starting here at 0, is 0 up, and then as we increase our angle, as we increase our angle, this goes up to 1, and then down to 0, and then down to -1, and then back up to 0, right? And it just keeps repeating that pattern as we go over and over and over and over again, right? And it might be easier to just mess with this on your own computer. But you can see it just keeps repeating the pattern. If you go backwards, it goes backwards on this. And all it's talking about is the distance up and down. Cool? Great, so try that out on your own. Here's the link. Pretty good, pretty straightforward. You can also graph this, right? So throw it in your calculator and just plug in sine of x, y equals sine of x. You might have to do a little fussing with the window, right? So plug in -2 pi and just use the pi button. Don't put in 3.14, just go -2 pi. So your graph will start here at -2 pi and then go up to 2 pi right here. And then x scale, it means how often do you want me to make a little hash mark? Make it every pi thirds or pi halves. I guess this one's pi halves. So make it every pi halves. Just see what happens. So that'll go 1, 2, 3, right? So you'll have a couple of marks. And you'll see it's going, oh, you want the maximum up at 1 and the minimum up at -1 and the scale to be like every half. So you'll get something sort of like this. And you'll see that it starts here at 0. At pi halves, it goes up to 1. At pi, it goes down to 0, -1, etc. Bam, 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 bam. Cool? Make sure you can do that. If you run it like this, you would probably want your window in radians. if you want to do this in degrees, make sure these are negative 360 and 360, and then go by 90 or something like that for the scale. Cool. Great. So make sure you can graph it. Yet another visual. If you break this into pieces, see this steeper piece right here. Let's do it in purple. This steeper piece of the unit circle is this piece. And then this more flat piece we've broken apart, and it's this piece, right? And then we have the flat part of this. Oh, the steep part of this right here. And so we're just kind of breaking this unit circle into pieces and assembling it into sort of a more linear pattern. Cool? There's another visual, and then here's another visual as well. You can kind of break all of the points up and put the points actually on the line. Just kind of drag them over and put them here. You drag this over and put it there. Boom, boom, boom. And you get this curve as well. So a lot of ways to see this. All right, so I want you to pause me and graph from negative 2 pi to 2 pi. Yo, okay? I'm going to do it quick. I guess you can just mute me because I'm going to play my own theme song music as I graph this. And you go from there. Here's a little unit circle to help you. And give it your best shot. Okay, go. So starting at 0, pi goes up to 1, negative pi back to here, just go down to -1, to pi there. Right, and then this goes backwards, so negative pi halves, if we went backwards, pi halves, that's -1, so this is down at -1. Negative pi is going over to here, so that's back here. This and that. Fabulous. There you go. Cool. Don't be like Mr. G's nasty looking pointy sine curves. These are nice arcing sine curves, so they should be nice arcs like that, like not shark fins or shark teeth. Cool. Great.